Welcome, crew, to our 3-2 notes on general sinusoidal graphs. Let's start with the definition of a sinusoid. A sinusoid is a function whose graph has the form of y equals the sine of theta, right? Or, as I've told you before, it is a transformation, so a dilation or a translation of either the graph of y equals the sine or the graph of y equals the cosine. So where we're going to begin today is knowing those graphs. Here's the graph of y equals the sine. It's a wave. Its domain is negative infinity to infinity, so it continues forever to the left and forever to the right. Its range goes from -1 to +1, never goes any lower nor any higher than -1 and 1. Its sinusoidal axis is the line that cuts through the middle of this graph horizontally. So if I come right through here, that is my sinusoidal axis. So its sinusoidal axis is the line y equals 0. The period is the number of degrees it takes for it to repeat itself. So if we look at the beginning of this wave at 0, right, it completes what I call an umbrella-shaped curve as it comes up here, and then it switches to a bowl, and at 360 degrees it starts again as an umbrella. So its period is 360 degrees. That's the number of degrees it takes to complete a cycle or a wave. The y-intercept for the sine curve, y equals the sine, is 0. So that's our graph of the sine. Let's look at our graph of the cosine. So for y equals the cosine, looks very much like the sine. It also has a domain from negative infinity to infinity and a range from -1 to 1. Its sinusoidal axis is also at y equals 0. And when we look at its period, at 0 degrees, this starts at the top of one of our umbrella curves, and it comes down, right, switches to a bowl, then comes back up to the other side of the umbrella, right, before it starts coming down and repeating what we saw at the beginning. So like the sine, it has a period of 360 degrees. It takes 360 degrees for the graph of the cosine to complete one wave or cycle. Its y-intercept, unlike the graph of y equals the sine, is 1. It crosses the y-axis at 1. Now, let's look at the elements of a transformed sinusoid. We're going to see a lot of the words repeated. As we look at this, what we have here is we have a wave, looks like the graph of the sine or the cosine. This graph is being based off, right, that right-hand side of our umbrella, a full bowl, and then the left side of the umbrella. So this is a transformation of y equals the cosine of theta. So it's not the cosine, but it's a transformation of that curve. So this one piece of the wave is called a cycle. So the number of degrees it takes to complete that wave is called its period. The sinusoidal axis is the midline horizontally of that wave. So it cuts that wave in half horizontally. So this is cutting that wave in half. Right? The height of the wave from that sinusoidal axis to a peak, or the distance from the sinusoidal axis to the very bottom of the wave, is called the amplitude. So let's take all that and let's put that and a few more things in writing. So our amplitude is the height of a wave. And that is from the sinusoidal axis, I'm going to use SA for sinusoidal axis, to a vertex of that wave. Okay, so a high point or a low point. The period is the number of degrees required to complete one cycle or wave, both expressing the same thing. The sinusoidal axis is the horizontal midline of the wave, so it cuts that wave in half horizontally. The phase displacement marks the beginning point of one cycle, and that can be a phase displacement for a cosine wave, which would begin at a peak, or the phase displacement of a sine wave, which would begin at the sinusoidal axis. The upper bound is a horizontal line through the upper vertices, so the high points of the wave. And the lower bound is a horizontal line through the lower vertices, or the low points of those waves. Okay, a couple more things here. Our inflection points are our points where the curvature changes. So they're where the umbrella switches to a bowl. Okay, they're always points on the sinusoidal axis. So they're points where the curve crosses the horizontal axis. The critical points are our vertices. So they are at the top of umbrellas, and at the bottom of our bowls. There are high points and our low points. Okay, so that's our terminology. Let's apply that to a transformation. First of all, these are the general form of sinusoidal equations. So they're either based off a cosine function or a sine function. And I'm going to put brackets here because all of this is what is inside our cosine or our sine. So we have a number that is added, right? So that number is added outside. That's actually going to give us a vertical translation. Then we have a number multiplied by our function. That's going to give us a vertical dilation. Then within our function, we have our variable, which is theta instead of x. We have a number subtracted from that variable. That's going to give us a horizontal translation. And then we have a number that's being multiplied inside our function. That's going to give us a horizontal dilation. We're going to call those numbers C, A, B, and D. A, right, whether this is positive or negative, so the absolute value of A gives us the amplitude of our wave. That is, it is the height of the wave, which is the distance from the sinusoidal axis to either a high point or a low point. So we're just going to say to a vertex. B, that's the number inside the function that's being multiplied by the variable. B is actually the reciprocal of the period. So B by itself doesn't give you an element of the wave. We have to do a tiny bit of math with B. And to find the period of the wave, we're going to take 1 over B, its absolute value, and multiply it by 360. Or we can say that that is 360 degrees divided by the absolute value of B. And what that gives us is the number of degrees per wave. Okay, that's our period. Frequency is another thing we talk about when we have waves. And the formula for that frequency is the absolute value of B divided by 360. Okay, now you should note that these are reciprocals of each other. Okay? So that makes these easy to remember. They are reciprocals. So if you know the period, all you have to do is flip it or put it under 1 and you have the frequency. If you have the frequency, you just have to flip the frequency or put it under 1 and you have the period. And that frequency gives you your number of waves per degrees. And so that's the multiplier inside the function. C is the location of the sinusoidal axis. Now our sinusoidal axis is a line, and its equation will be y equals c. C is what's added outside of the function. D is what we call our phase displacement. We would have called it in our first unit our horizontal shift, and that's going to mark the beginning of a cycle. So let's look at an example. I have the equation y equals -5 plus 3 times the cosine. Again, I'm going to put brackets here of 4 times theta minus 10 degrees. Okay. My first number is my C. My second number is my A. Inside we have our B, and then subtracted from our variable theta we have our D. So let's see if we can answer our equation. What is the equation of the sinusoidal axis? Well, the equation of the sinusoidal axis is y equals c. So it's going to be y equals -5. What is the amplitude? Well, the amplitude is always the absolute value of A. So our amplitude is 3. Where is the upper bound? Your upper bound is always your C plus your A. So for us, our upper bound is -5 plus 3, or -2. So my upper bound is the line y equals -2. The lower bound, your lower bound is always C minus A. So for us, our lower bound is -5 minus 3, which is -8. That is the line y equals -8. So our sinusoidal axis, our upper bound, our lower bound, all horizontal lines, all with the equation y equals are constant. What is our phase displacement? Right? Your phase displacement is D, right? And you always work with the opposite direction of the sign. Remember, inside is inverse. So since our D is 10, right, and we are subtracting 10, that tells us that our phase displacement is 10 degrees to the right. What is the period? Remember, the period is 360 degrees divided by the absolute value of B. So for us, our period will be 360 degrees divided by 4, which is 90 degrees. It takes 90 degrees to complete one cycle. All right, great information. Let's see if we can use that now to graph a sinusoid. All right, so to graph the sinusoid, we're going to go through these steps. Right? I'm going to let you read those steps, right? We've got all these steps, and we're going to do it with our example problem. So here we go. We have y equals -5 plus 3 times the cosine, right? Putting that in brackets of 4. Okay, so I know that, right, we're going to start with our sinusoidal axis. So I know that our sinusoidal axis is at y equals, right, our c value, so -5. So I'm going to come in here and I'm going to do a little dotted line horizontally. That's going to be my horizontal axis. My sinusoidal axis. So this is my sinusoidal axis, and it is at y equals -5. And now we're going to sketch our upper bound. So above this line, I'm going to come in here and I'm going to do another little line. And you'll notice I didn't start with my X and Y axes. I'm actually going to lay those in later. So I'm creating like writing paper that you used back in elementary to help you make letters the right size. So that upper bound was at -5 plus 3. So that was at y equals -2. And at -5 minus 3. So that was at y equals -8. The next thing I'm going to do is I'm going to come in here and I'm going to mark my phase displacement with a vertical dashed line. So I'm going to come in here about 1/3 of the way in on my paper. So I've got room to do 3 cycles. So I'm going to come in here and that's going to be at x equals 10 degrees. Our phase displacement was 10 degrees to the right. And then I'm going to mark the length of the period with another dashed line, which I'm going to do about 2/3 of the way. And that's going to be y equals where I began, 10 degrees, plus my period, which was 90 degrees. So that's going to be at x equals 100 degrees. If I were doing this on paper, I would do this in pencil so I could go back and erase some of it later. Okay. Finally, I'm going to come in here and I'm going to mark my critical points and my inflection points. And to do that, I'm going to do a little bit of math. So I'm going to come in here and I'm going to take my period and I'm going to divide it by 4. So in our case, we have a period of 90 degrees. We divide that by 4 and that's going to be 22.5 degrees. So I'm going to come in here on my sinusoidal axis and I'm going to split this place in half and then again each half in half, so I have in fourths. And what I'm going to do is from the beginning, I'm going to add 1/4 of a period. So if I add 22.5 to 10, then this mark happens at 32.5. I add 22.5 to that, and now I'm at, what would that be, 55. Add 22.5 to that, so we're adding 22.5, and now I'm at 77.5. And if I add 22.5 to that, then I'm at, no, shoot. Then I'm at 100 degrees, which is exactly where I wanted to be. Okay, so again, I'm going to do these in pencil because I'm going to come back and erase them. Now I'm going to come in here and I'm going to sketch one cycle of the graph of the cosine in this box. And you'll remember from our earlier activity that the cosine curve goes high, mid, low, mid, high. So when I do my cosine curve, I'm going to start high at the beginning of the cycle, then I'm going to go mid, then low, then mid, and then high. I'm going to come back in and I'm going to sketch this curve. Right? Shouldn't be pointy, should be curvy. And that is one cycle of the curve. Now I'm going to repeat this to the right and the left, and I'm not going to be quite as picky with my numbers, but I'm going to come out from here an equal distance here. So here's going to be another 90 degrees forward. So I add 90 to my 100 and I'm at 190 degrees. And I'm going to go back an equal distance, so that's going to be 90 degrees backwards. So that's going to be at a -80 degrees. And I'm going to repeat my cycle. So splitting this in fourth, I go high, mid, low, mid, high. Coming back, again in fourths, I'm going backwards this time, high, mid, low, mid, high. And I have done a graph of my sinusoid, my transformed cosine. All right, it's your turn. Work on that.